How would you describe EDD in one word?
Collaborative.
Community.
Resourceful.
Challenging.
Empowering.
Opportunity.
What is EDD?
ED is not your ordinary class experience. Engineering, design, and development puts you through a more professional and more real-world-like experience where together a group of students are tasked with a mission and completed throughout the entire year. We founded our company, Invicta Technologies, where we're tasked to create a SnakeBOT and a drone to be able to take that snake and navigate it through difficult terrain. Now, throughout this entire year, us, Invicta Technologies, strives to break boundaries through perseverance and complete this mission together.
And what is our mission?
The mission is scheduled to be executed in a simulated environment, henceforth referred to as the arena, consisting of a reasonably flat surface with 2 to 3 environs to be explored by the robotic systems. The mission is split into 2 systems, ground and aerial. The ground system is a biomorphic, hyper-redundant, semi-autonomous robotic system. Wow, that's a mouthful, so from now on we'll be referring to it as a SnakeBOT, capable of transporting itself over various terrains that even traditional rovers cannot traverse. The aerial system is an aerial drone whose task will be to collect/release the SnakeBOT and transport it to the next target environment, all while providing processing and electrical power to the tethered SnakeBOT for a minimum of 20 minutes of operating time, while also operating itself for double that time. The SnakeBOT will be allowed access to the intended sites through a 6 to 8 inch diameter opening. The SnakeBOT must be able to stand up to a third of its length and be able to climb up and down a pole. The SnakeBOT will also be equipped with robotic vision and send a live video feed to the operators. In one of the environments, a small soil sample must be collected to be later processed on the onboard biochemical laboratory chamber mounted on the aerial drone. Using an extendable tongue, the SnakeBOT must be able to detect the temperature of the environment and the drinkability of a newly discovered water source. Some of the environments may hold evidence of a prior civilization's presence. The evidence collected may be physical or images for later review. The company who can collect the most data in the operating timeframe and demonstrate the most mastery over the required tasks will be declared the winner of the competition.
With that out of the way, what was our initial plan?
So we kind of just started on the whiteboard, just kind of sketching out a bunch of different ideas. And then after that, we went on a paper version of the sketch, also kind of doing the same thing, but just more detailed and descriptive so we could move on to CAD. So we used Fusion 360. We kind of taught just a bunch of different people in mechanical and manufacturing how to CAD. And we split our CAD team up for the tail, the head, and the body of the module, or the body of the entire snake. And based off that, we just kind of worked and tested out different iterations with it.
So we were working with sort of a size constraint and a complexity constraint. The biolab itself is really simple. There's no moving parts. So what we're really going for is not to test for like actual organisms, but the byproducts of those organisms. So the concept is that we feed the bacteria that exists in the soil, and then we test for their byproduct with a pH electrode. So that would like refer to like the Krebs cycle, with an output being CO2. So we're testing for like pretty much production of carbonic acid that would change the pH a little bit.
For water potability, our design is basically like a snake tongue. It just goes in and out of the mouth or the head. While the snake is moving, it's contained within the head to protect the sensors because some of them are kind of like easy to damage. And then once the snake reaches a water source, the tongue will extend out and go into the water and take readings. The kind of data we're using, because we can't do a long-term test, we have to do something that happens like right away. We're just going to be measuring things such as total dissolved solids, turbidity, pH, and temperature. And also, hopefully, we can get Prague to do a visual analysis for us, but we're still working on that.
Well, one of the more challenging pieces of the biochem lab to accommodate our drone is the 8-inch electrode for the soil sample. So we contemplated many configurations, like if the 8-inch electrode was going to go downwards or side to side. Eventually we decided to have it at a little bit of an angle because we really didn't have the space. That would impact our stability and everything else, our weight. So we decided that we needed to have it at an angle.
So initially, after looking at the game reveal video, I knew that it was going to be approximately a $10,000 project. Over time, we have been looking for alternatives to anything that we could find. So we were able to save about $2,000 to $3,000. So this is now approximately a $8,000 project compared to the $10,000 that we initially thought. Given the fact that we've been doing fundraisers every week, we have usually fundraisers every Wednesday, and if we can squeeze in more fundraisers in the week, we try to. A lot of this is just student raised, given our lack of donors at the moment, but we are trying to get more donors to hopefully alleviate that for finance.
As Letty, as also being the director of interns, what was it like to lead the interns, and what was your process in guiding them to success?
I think for me, it was pretty easy to kind of decide which ones we needed, especially since our class needed a lot of technical experience. So when selecting the interns, we took into consideration the needs and, the recommendations of the directors. And so when we selected them, the best way for us to guide them to success was to kind of help decide what their intern project was amongst the directors, and then assign them roles so that they have responsibilities that they have to complete, and then it kind of fell into place from there.
I need to zoom in. Hold on.
We will do our best. That's what we do. We know what we're talking about. You go up there, speak with confidence.
Invicta! 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 Invicta!
What was your experience in participating in SPS?
Overall, it was really stressful. I think that as an admin member, there was a lot to organize given there's like 9 departments. And when you don't manage our time correctly, it causes a lot of issues for the advances of the project as a whole. So yeah, it was really stressful. But overall, it went really well because the teams managed to pull through on everything.
So today I was working on mainly the CAD assembly of our snakehead robot. I was basically piecing together different CAD files and putting them in assembly and making it look like what we're gonna have in real life. The pH sensor goes to the tongue of the snake head. Basically it attaches onto a rack that would move with a gear. And we basically slotted that rack to make sure that it would be structurally stable whenever it would flip or just move.
So today we were testing the electrical systems on the drone, and it was just basically doing a step-by-step, one-by-one of each component on the drone to make sure that there were no problems with clarity or anything like that, and making sure that everything was complete and was a closed circuit.
Yeah, so after that's done, we're going to be working on setting up the rest of the electrical systems and burning for the drone. So right now we're sure that all of our components are functional, or all the electrical connections are safe and won't short like previously. So we're sure that all of our electrical connections are safe and will be safe for the future during flight. So now we're working on setting up all the necessary software components. So this includes setting up the compass, which allows the drone to maintain a steady level while flying. And we're also setting up different things like our radio input, which allows us to control the actual drone. And we're also going to test the motors themselves, as even though we've turned them on, we haven't tested that all of their speeds are the same and that they're going in the right direction. So once we're done with that, we're pretty much ready to fly.
And now, the day we've been looking forward to. As Exagora's drone was preparing for liftoff, 2 of the propellers came off and hindered their chance to get points. But with every struggle comes its victories, and Exagora's snake was able to secure points by entering the cave and making it out. But now, it was our turn to complete our mission. Even though our snake wasn't functional, and our drone hadn't been tested for flight yet, we went in and tried to complete the mission. And even with a minor setback, we were able to transport the snake to the cave.
Okay, down!
With Exagora's drone unable to fly and our snake unable to move, it was all up to previous presentations and progress tracks to determine the winner. With the end of our mission, we grew together as a team and persevered through boundaries with perseverance. We are Invicta Technologies.
3, 2, 1, break!